All right, let's try and explain this problem. So here we go. We talked about it a little bit in class. You got a solid obtained by rotating this region, um, bounded by the curve, the blue curve, x equals y minus 2 squared, and then the red line, which is just y equals x. And you're rotating it around the line, um, y equals -1, so down here. And so what we're going to do is we're going to make cylinders, okay? We're going to make cylinders, and we need to multiply the 2 pi radius height times the thickness. So we know that the thickness is going to be dy. So right here, this tiny thickness right there is a small change in y. Now, where do those two curves meet are going to determine our bounds. All right. So what you'll notice is when we think about where those two curves meet, or where y is equal to y minus 2 squared. That's where if you set x is equal to x. If you set those equations equal to one another. So we get y squared minus 4y plus 4 equals y. And then if I subtract that y, I get y squared minus 5y plus 4 equals 0. Or graphically, we can notice, but if we factor, we're going to get y minus 1 and y minus 4. So those are the zeros, and those are my bounds over here on the left. Okay? And so I've got the boundaries, 1 to 4 for y, meaning that I'm going to start adding when y is 1. And notice that for this first cylinder, that would be the radius, would be the height would be y from the x-axis up to that, plus 1 for what's below. So we would have y plus 1 is going to be our radius. I just realized I'd done everything wrong, so it's okay. Okay, so y plus 1 would be our radius, meaning that for this first cylinder, say right here at the bound of 1, the radius of that cylinder would be 2 units. 1 plus 1 would be 2, because the distance from here to there would be 2 units. Okay, or the y value plus 1. And then at the end, when we get that radius, that last radius, it would be 5, because you got 4 units from the x-axis plus the 1 more below. All right, and then our height of our cylinder is going to be the difference. All right, we see this over here. Our height is going to be right here. And that's the difference between the rightmost curve, which is the largest x, minus the left curve, the blue curve, which is the smaller x. And so that's where we get this y minus 2 squared. All right. So the rest, you can just plug that in directly into your calculator if you want, or you can go ahead and do it analytically. I'm going to do 2 pi from 1 to 4 y plus 1 times y minus 2 squared dy. And that's going to be my value. So let's go to our calculator and let's see if we can figure this out. Can't get it to change size. Let's see if I can figure this out. Okay, there we go. Come on. So, okay. So I'm going to try and do this all in one stroke. So 2 pi. Then I want to go math, and I'm going to integrate from 1 to 4. And then inside here, I want to use some groupings. So y plus 1. And again, I'm using my x variable, so it doesn't matter if I use the same variable all the way across, times x minus another x minus 2 squared, and then close my parentheses there. And then I want dx. So again, 2 pi, my radius is x plus 1, my height is x minus 2 squared dx. And I would change all those to y and it would give me the same result. 98.96 is going to be my approximate value. Analytically, we might get something a little bit prettier.